our mathematics lesson. Are you ready for the lesson? Okay, I really hope so. Right, we're going to continue with our Euclidean geometry, but today we're going to concentrate on the tangent theorems. Okay, we're going to look at the tangent theorems and their converses. Okay, right, remember what we did in the previous lessons. We did the center theorems, and then we did the cyclic quadrilateral theorems. So today we are looking at what? The tangent theorems, the theorems that have the tangent. Okay, right, now let's look at the objectives. You will prove examinable tangent theorems. Remember, I said that every paper will have a proof question. One of the theorems will be there in the examinations. So you have to know how to prove all these theorems that we tell you that they're examinable. Okay, right. And then apply theorems and their converses in typical examination questions. Okay, right. That's what we're going to do in today's lesson. So I want you to be ready for the lesson. Okay, you're not sitting there and just watching me. Your book should be in front of you, your pencil, your pen, your calculator, and even your ruler. Okay, let's have all those things on our desk and you are ready to learn. Okay, right. Now, let's look at the theorems. What we're going to do, we're going to go through all the theorems that we're going to learn about today. Okay, and then after that, we'll look at the proofs and also the applications. Okay, right. I want us to discuss all the theorems. There are not three of them. No. All the theorems, we're going to do that first. And then after that, we're going to look at the application and the proofs. Let's look at the first one. The tangent to a circle is perpendicular to the radius or diameter of the circle at the point of contact. I'm going to give you 2 minutes. I want you to try and draw the circle with the tangent and what is just representing this theorem using a diagram. I want you to try that. Draw your diagram, okay, being informed by what? By this theorem, which says that the tangent to a circle is perpendicular to the radius or diameter of the circle at the point of contact. Try to draw this diagram. Okay, right. The tangent to a circle is perpendicular to the radius or diameter of the circle at the point of contact. Draw the diagram, and then after that I'll give you my diagram, and then you can compare and see if my diagram and your diagram are the same. Let's try that for 2 minutes. Let's try. Right, welcome back, grade 12. Did you manage to draw your diagram? Let's compare our diagrams. Do you have a diagram like this? Right, we are saying what? The tangent. Which one is the tangent here? Okay, it is the AC, tangent AC. Do you see the tangent AC? This is the tangent AC. It is perpendicular to the radius. You see, this is the radius or the diameter. I can extend this and make it diameter. Right, it is perpendicular. These two things are perpendicular to each other, the radius and the tangent. So the meeting here, remember what a tangent is. A tangent touches the circle at one point. So at that point, and is where the radius meets the tangent, so they will be perpendicular to each other. So a tangent is perpendicular to the radius or diameter at the point of contact. At this point B here, the tangent and the radius are perpendicular to each other. Perpendicular means how many degrees? It means 90 degrees. Do you agree? Okay, right, let's look at the converse. Or before we look at that, what's the reason that we use? We say tangent perpendicular to radius or tangent perpendicular to diameter. That's the reason you write. You can say angle AOC is equals to 90 degrees because it's tangent perpendicular to radius. Or angle A, what did I say? Did I say AOC? No, it's OBC. OBC, this angle, OBC, is 90 degrees because it's tangent perpendicular to radius. Or angle OBA, OBA, okay, OBA is 90 degrees because tangent is perpendicular to radius, okay? Right, what is the converse of that? What can you say? If a line is drawn perpendicular to the radius, okay, now the line is drawn perpendicular to the radius, what can you say about that line? What type of a line is that? Okay, a line perpendicular to radius at the point where the radius and diameter meet, radius or diameter meets the circle, then the line is a tangent. So that line is a tangent. So it is the converse of that. So with the reason there, you can say converse. This one I think is very simple. You just add the word converse in front of tangent perpendicular to radius or line perpendicular to radius. Okay, or converse, okay, tan perpendicular to diameter is the same thing. Okay, so that's the converse of that theorem. Right, now I'll be asking you to draw the theorem, then the converse I will just discuss. Okay, right, let's go to the next theorem. Now the angle between the tangent to a circle, the angle between the tangent to a circle and the chord drawn from the point of contact, okay, the angle between the tangent to a circle and the chord drawn from the point of contact is equal to the angle in the alternate segment. Does that make sense? Let's try. I'm going to give you 2 minutes to try to draw this diagram, okay, which is represented by what? By this statement here. The angle between the tangent to a circle and the chord drawn from the point of contact is equal to the angle in the alternate segment. Okay, 2 minutes. Can you try to draw the diagram for this theorem? Let's try. Right, welcome back, grade 12. Did you manage to draw the diagram? It says what? The angle between the tangent to a circle and the chord drawn from the point of contact. Which angle are we looking at here? What do you think? Okay, according to my diagram, I know that you may have a different diagram there, it's fine, okay? But when you compare your diagram and my diagram, they must be similar. Right now, according to my diagram, which angle are we looking at here? It can be B2. Do you see B2? It is an angle between a tangent, the angle between the tangent and the chord drawn from the point of contact. You see this? This is the chord BD, and then this is the tangent here, and then this is the angle B2 here. So this angle B2 is equal to the angle in the alternate segment, the other segment. We're going to talk about segments very soon. So it means this is like this. So this angle E is equal to B2. Okay? Even if you check this side, you can have the same thing. You can have the same thing. Right. Now, you can have this angle this side. You see, this is the tangent up to the point of contact. Then you follow the chord. And then this angle here, B1, is equal to the angle subtended by the chord in the alternate segment. It means this side. So, B1 is equal to angle D there. Do you see that? That's what is meant by that theorem. Okay? Right, so don't forget that. But we're going to discuss these theorems in detail. Okay? I'm just giving you highlights now. Okay? And I want you to visualize, to be able to try to draw these diagrams on your own. Right. Now, the reason you just say tan chord theorem. Tan chord theorem. Okay? We've done two reasons today. Tangent perpendicular to radius or tangent perpendicular to diameter. And then the tan chord theorem. Okay? Right. Now, the converse. A line drawn through the end point of a chord, making with the chord an angle equal to the angle in the alternate segment. So we're saying a line drawn through the end point of a chord, like this one, making an angle with the chord, making this angle equal to the angle in the alternate segment. Then the line, this line AC is the tangent. You see that? That's what it means. You're drawing the line AC through the end point of the chord. Okay, through B here. Making with the chord an angle, this angle, equal to the angle in the alternate segment equal to this one. Then the line AC is the tangent. Same with this one here. You can even have this side. Right. Let me use different color. Right. Same with this angle here and this angle here. Same thing. This angle is equal to this angle. Then the line AC is the tangent. That's the converse of that. Okay. Right. Now, so now just write converse of the tan chord theorem. Okay. Or angle between line and chord. You can write those reasons. I find this one easier because already we know the reason for the theorem, which is tan chord theorem. So the other way around is the converse of tan chord theorem. Okay. Right. Now, another one. I want you to try this one. Okay. Two tangents. Two tangents. How many tangents? Two. Drawn to a circle. Drawn to a circle. Remember, a tangent will touch the circle at one point. From the same point. From where? From the same point outside the circle. So I have two tangents drawn from the same point outside the circle. Okay. These two tangents are equal in length. I want you to draw a diagram for this. Okay. This one, it should be easy. Just two tangents from the same point outside the circle. You draw them. They touch the circle at one point. Okay. Each. And then now, can you try to draw that diagram? Okay. 1 minute. And then after that, I'll show you mine. Let's try. Well done, grade 12s. Well done, well done. I know you're trying your best. You're trying your best. Things may look difficult. It's fine. It's okay. We're learning, isn't it? You're enjoying mathematics. You're getting things right. Keep it up. Well done. Continue trying. Okay? Right now, we're saying this is what? We have two lines drawn from the same point. From A, this line goes, it's a tangent, then it touches at point B there. Touches the circle at point B. Then this one goes, touches the circle at point C there. Please remember the distances we're talking about here is AB and AC, not up to here. Don't worry about that. Up to the point these tangents are originating from, up to the point where they touch the circle. That's the distance, that's the length we're looking for. So we're saying AB, in this case, AB is equals to AC. Okay, so this is equals to this. Up to here, from there up to there. So we're saying that two tangents drawn to a circle from the same point, okay, outside the circle are equal in length. Okay, so what's the reason we write here? We say tangents from the same point because the tangents are drawn from two tangents drawn to a circle from the same point, isn't it? So it's tangents from the same point. That's the reason. We have done how many theorems so far? We've done the theorem that says that the tangent is perpendicular to the radius or diameter. And then we've done the one which says the angle between the tangent and the chord is equal to the angle in the alternate segment. Okay, tan chord theorem. And then now we're saying that two tangents drawn from the same point, okay, right, drawn from the same point outside the circle are equal. Okay, these are the theorems we're going to be concentrating on today. Right, I really hope that you understand these theorems. We're going to discuss them in detail, and some of them, those that are examinable, we're going to do the proofs. Can we move on? I think so. I think so. Let's try to move on. Now, we're going to do like we did in the previous lesson. Remember that you must read the information and try to fill in the writer, and then after that you what? You try to answer the questions. Are we ready to do that? Okay, I hope you're ready. Right, ABC is a circle. Do you see the points A, B, and C? These are points on the circumference of the circle. And then the center O. This gives us a guideline. Center O is to do with what? With the center theorems now. Okay? Right. DE is the tangent. Okay? And I don't want you to use the tangent for now. I want you to use the center theorems. I haven't taught you the tan chord theorem, okay? The center theorems. And the tangent perpendicular to radius, okay? Tangent perpendicular to radius for now. Tangent perpendicular to radius and the center theorems. I want you to use that, then I want you to observe something. Right, DE is the tangent and EAB is 40 degrees, okay? But some people can even recognize those using the tan chord theorem. Is still fine, but for those, I want you to observe something. I want you to observe something. But if you already know, it's fine. We are revising. Right. Determine the size of angle X, Y, and Z. Okay. Right. I'm going to give you 2 minutes to try and fill in the information on this diagram. Okay, right, 2 minutes, maybe 1 minute you're trying to draw the diagram, just a rough sketch, and then the other minute you're trying to fill in the information. Okay, let's try that. If there's someone can go to the board and assist each other, it's still okay. You can decide in the classroom what you want to do, but now we can even discuss as a class. Okay, not as individuals, you can discuss as a class there. What do you think that angle is? Just recognize things on your own. Okay, try to do that. I'm going to give you 2 minutes. Welcome back, grade 12s. Interesting. Interesting. Right, how many people recognize that Z is 40 degrees using the tan chord theorem? Well done. There's nothing wrong about that. Z is 40 degrees using the tan chord theorem. How many people recognize that Y is 90 degrees? Okay, why is Y 90 degrees? We can talk about angle in the semicircle, an angle subtended by the diameter, and then we can talk about the angle, the tan chord theorem also here of OAD, because OAD is what, 90 degrees. Okay, right, if you recognize those, perfect, excellent. Okay, now let's try to move together. Right, I'll say here OAE, this angle here is 90 degrees. Even if your own way of doing things, I'm not saying your way is wrong, okay? It is different, but may be correct, isn't it? Okay, but let's try to do this together. Right, what can you say about this angle OAE? It's 90 degrees. Why is it 90 degrees? Because the tangent and the radius are what? Are perpendicular to each other. Do you see that? Okay, the tangent is perpendicular to radius. Okay, so now it means x here, I'm going to say 90 minus what? 90 minus 40. It means this should be 50 degrees. Okay, right. I can say y is 90 degrees. Y, angle in the same segment. Sorry, not angle in the same segment. No. Okay, angle in the semicircle. Angle is subtended by the diameter. Sorry for that. Angle subtended by the diameter. Do you see AC is the diameter? Diameter subtends a 90-degree angle. So now y is 90 degrees. Okay? And then we can say 50 plus 90 is equals to 140. And then we say 180, because these are angles in a triangle here. Z, X, Y are angles in a triangle. We say 180 degrees minus 140 degrees. This is 40 degrees. Do you see that? Okay. Now, you see? And then here, can you say this is 90? OAD is 90 degrees because OA is radius and DE is the tangent. Okay, you see that? Now we can answer our question. Let's go back to our questions. Now, what will be the value of X? Okay, I'm going to give you 1 minute to find the value of X, the value of Y, the value of Z. I've given you answers, but now I want you to try on your own. For 1 minute, find the value of X, Y, Z, and then after that, we just discuss. Let's try. Welcome back, grade 12s. Was 1 minute enough? I think so, because I gave you answers. grade 12s, so you cannot complain and say it was too short. But let's do it together anyway. We're going to move together slowly. Right, now, what did you get for X? We said this angle here, OAE, is 90 degrees because the tangent is perpendicular to radius. So this angle here is 90 degrees. So now to find X, we say 90 minus 40. So it means X is 90 minus 40, which is 50 degrees. So X is 50 degrees there. Okay, did you get that? Mark your work. So you can write your 50 in the diagram. Right, now, what about Y? What did you get for Y? Okay, we're saying Y is going to be 90 degrees. Why? Angle in the semicircle. Okay, angle is subtended by the diameter at the circumference. So y is 90 degrees. So do we agree? So we can put our sign there or symbol for 90 degrees, which is that. And then what about y? There are angles in a triangle here. So y is going to be what? Y, not y, sorry, z is going to be what? We got this one 90, y, want z. So z is going to be what? 180 degrees minus 90 minus 50 is going to be 40 degrees. So z is 40 degrees, okay? I want to ask you this question. What do you observe? Look at these angles. Look for angles that are equal. Look for angles that are equal. Okay, what do you observe? Okay, what do you see? This angle is equal to which angle? The angle in the alternate segment is equal to that angle. Do you see that? And this is the tangent and the chord. You see that? The tangent and the chord. So the angle made by the tangent and the chord is equal to the angle subtended by that chord in the alternate segment. That's the tan chord theorem. You see, even this side. What about this angle? EAB is equal to, we've done that. What about this one? Where is it? OAD, which is this one. You see, it's 90. Okay, this is the tangent. This is the chord. And then this chord subtends this angle 90 on the other side, there, on the alternate segment. Do you see that? Okay, these two angles are equal. This is 90, this is 90. Okay, right, let's try another activity. And then we're going to observe the same thing. Okay, right, now, ABCD is a circle with center O. BD and AC are the diameters of the circle. EF is the tangent and BAF is 25 degrees. Determine the value of the size of angle X, Y, and Z. Okay, try to read the information. Let's read together, and then after that I'll give you time to discuss the diagram or the writer. ABCD is a circle with center O. BD and AC are the diameters. What comes to your mind when you talk about diameters? Angle is in the semicircle. Right, and then EF is the tangent, and then BAF is what? Is 25 degrees, okay? Right, now, I want you to try to... Okay, let me go back to the thing. Yeah. I want you to discuss this diagram for 1 minute. Okay, try to fill in the angles there. Okay, you can even find what your X is, even what your Z is, what your Y is, even the other angles that you're not even asked to get. Try to do that for 1 minute. Okay, welcome back. Sorry, grade 12s, welcome back. Now, let's look at our diagram. Right, what can you say? OA is the radius. OA is the radius, and then EF is the tangent. So this angle here is going to be 90. You see that? It's going to be 90. And then X is going to be 90 minus 25. Do you agree? So X is going to be 90 minus 25, which is going to be 65 there. Okay? Is it fine? I think so. 65. 90 minus 25 should be 65. And then let me write here. If I'm wrong, I'm not sure. But I think so. Right, now, And then what about this angle ABC? This one is going to be 90 again because it's subtended by the diameter AC. Okay, so it's subtended by diameter AC there. So this is going to be 90 degrees. Okay, and then you can find y here. You see, 90 plus 65, you get 155. Okay, and then you subtract 155 from 180 because these are angles in a triangle, right? Then you can get your y here. Okay, it must be 25. It must be 25 degrees. Okay, and then what about z? I can see these are angles in the same segment. Do we agree? Z and Y are angles in the same segment. They are subtended by the chord AB. Do you agree? By the chord AB here. Do you see this chord here? So Z and Y, they are angles in the same segment. Means Z also is 25. Okay? I think I have enough information. What else do I need here? Okay? This angle also is going to be 90. This one also is going to be 90, right? Okay. This angle also is going to be 90, this one, because of BD, the diameter there. Maybe I may not even need that, okay? Right now, let's go back to our question. I want you to use 1 minute to answer all the three, the size of X, Y, and Z, okay? Right, X, Y, and Z, okay? Right, let's try to, for 1 minute, find the value of X, Y, and Z. I've given you these answers anyway. So that's why I'm giving you 1 minute to try to think on your own. Try to remember what I said. Okay? 1 minute. Let's try. Right, welcome back, grade 12. Did you manage to find the value of X? We say that OAF, this angle here, is going to be 90 degrees. This is the angle which is 90 degrees here, OAF, because it's a tangent and radius, or tangent and diameter. Right, so therefore, X is going to be 90 minus 25, meaning that X is 65 degrees. So you can write your 65 degrees there. Okay, we found X. And then let's go to, want to find Y. Right. We can see, someone can see that Y is 25 already using the tan code. Okay. But we're still learning, isn't it? That's why I'm going this way so that we can discover things. Right now, and then Y, we can say this angle here is 90 because angle in the what? In the semicircle. And then you say 65 plus 90, we get 155. And then we subtract from 180 because these are angles in what? In a triangle. So we will get that Y is what? Is 25. You see that? Okay. Angle sum in a triangle. Okay. And then Y is 25 degrees. You see that? And then we said Y and Z, they are angles in the same segment. They are subtended by the same chord, or they are subtended by the same arc. So they are equal. So Z also is 25 degrees. Okay. Z is also 25 degrees. Okay. Right. Now, what do you observe? We've talked about this. You see that this angle, okay, FAB, where is FAB? This angle here, FAB is equal to what? It was 25, it's 25 degrees. It is equal to this angle here. Do you see that? So it's an angle with the tangent and the chord. I think the tan chord theorem, you'll even understand it before I even teach it. I haven't started talking about the tan chord theorem, but already you have an idea about this theorem. You see that? Now, okay, tangent and the chord. The chord is subtending that angle D there at the circumference. You see that? Do you have any other combination of tangent and chord theorem, tan chord theorem? Check this one. Okay, same is tangent and the chord. It's still chord AP if you check. Okay, we have this one also. These are 25. We have also these two, the tangent and the chord. Remember, diameter is a special chord, isn't it? It passes through the center of the circle. Right, also tangent is a chord. And then we have this one also, tangent there and the chord there. So these two angles also are equal. This is tangent. Let me use a different color. Right, tangent here and then the chord there. It forms what? Subtends an angle there by the circumference at B there. You see that? Okay, right. Well done, grade 12s. I really hope that you managed to use the theorems that we already know, and we're introducing the tan chord theorem there. Okay, right. Now, I want us to understand this. I wanted to give you this as an activity, but let's discuss this. Okay, and then because you have to do proofs, we need more time for that. Right, given a circle and its components, remember that DC is what? DC is a tangent. Okay, DC is a tangent. And then what is AB? AB is the chord. I'm trying to explain this thing of alternate segments thing, okay? Right, AB is the chord. So the AB, the chord, divides the circle into two segments. And most of the times, the segments are not equal. There is a bigger segment and a smaller segment. They'll be equal if the chord is the diameter, okay? But if the chord is not diameter, you are going to have a bigger segment and a smaller segment. The bigger segment is called what? The major segment. And the smaller segment is called the minor segment. So we have the major segment and the minor segment, okay? So now, look at the chord AB. So there's this angle that is formed by the chord and the tangent, okay? Right, there's this angle which is formed by the chord and the tangent, which is angle in red, ABT. You see angle in red, ABT. And then there is this segment here. So the angle that we're talking about is in the other segment, in the alternate segment. So we're saying we're talking about the major segment now. So we have an angle formed by the tangent and the chord. And the angle subtended by the chord in the alternate segment, which is this angle here. You see that? So these are the angles that we'll be talking about when I'm talking about the tan chord theorem. Okay, alternate segment. What is it? Okay, you need to understand that. Right, so section E, section F, we've talked about those. Those are segments. E is the minor segment, F is the major segment. Okay, please don't get confused there. Right, now, we're going to look at the proofs now, okay? The angle between the tangent to a circle and the chord drawn from the point of contact is equal to the angle in the alternate segment. This is the second time we're talking about this theorem, isn't it? Now we're doing the proofs. This is examinable. You have to know how to prove this, okay? So now we're talking about this angle being equal to that angle. You're saying the angle E is in the alternate segment, okay? Is in the alternate segment. I've emphasized this a lot. Let's go straight to the proof. Now, given tangent AC, I want to slow down now. I think I was moving fast. Now, given tangent AC, do you see tangent AC? We are required to prove, this means required to prove that CBD is equals to BED. I want you to identify those two angles. Just for 30 seconds. Identify those two angles. Angle CBD and angle BED. Right. I hope you've managed to identify the angles. Do you see the angles? CBD and BED. We're saying these angles are equal and we want to prove that. So this proof is very, very important. Right. I want you to spend about 1 minute drawing this diagram because we're going to do it together. Just try to sketch it if you can. Try to make it nicely. Make it big so that when you're sketching, constructing, things are very, very clear. Don't make it small. Even if it means using half a page, let's do that. Okay? Draw the diagram for 1 minute. Well done, grade 12s. Let me just explain this before we move on so that we don't get confused. Right, in this proof, we're going to do 3 proofs. The first one is proving for an acute angle. You know an acute angle? An angle between 0 and 90 degrees, less than 90 degrees. And then we're going to do the proof for an obtuse angle more than 90 degrees but less than 180 degrees. And then I'm going to show you an alternative method for an acute angle. So 3 of them, okay? Right, this is the first one. We're proving for the acute angle. Angle BCBD is an acute angle. Angle BED is an acute angle. So what you do, construction. That's the first thing you do. Remember that. Construction. What do you construct? You draw a line from the point of contact, okay, of the tangent and the circle and the triangle, isn't it? In this case, it's going to be B. So you draw a line from B through the center to the circumference. Okay? Draw a line from the point of contact through the center of the circle to the circumference. Okay? So now we're going to do that construction. Remember, you won't get marks if you don't do your construction. Right, now draw diameter BO and then F. So it means the point on the circumference, we name it what? We name it F. So that's the first one. Let's do that. Okay, let's draw a line. Let me also draw on top of my line so that I know. Once I'm done, everyone should be done. Okay, let me choose red ink. Right. Draw, dot, F. Everyone is done now. Okay, so, and then join F and E. Join F and E. And then you have something like that. We are joining dot. Right, now, do you see that? What do you see here if you look at this diagram? I can see angles subtended by diameter. We say angles in the semicircle. Do you see that? Because BOF is diameter. I can see angles angles in the same segment. Do you see FD subtends this angle here and then also subtends this angle here at the circumference? Do you see that? Okay, that's what we are going to use to prove this theorem. Okay, right, let's start. So now we are saying okay, I'm naming, let's name, forget. Right, B2, do you see where B2 is here? Name it. B1, name that one B1. And then E1, name it E1. Please follow my naming so that we don't get confused. And then E2, please name those ones. B1, B2 correctly like what I've done. And then E1 and E2 like what I've done. Okay, follow my naming, okay? Right, now, what can you say about OBC? What can you say about OBC? B1 plus B2 is 90 degrees. That is angle OBC. So this angle here is 90 degrees. What can you say about BEF? E1 plus E2. Why is it 90 degrees? Subtended by diameter. So these two are 90 degrees. So, okay. Let me show you. I didn't do animation here. Let me see. This one is 90. And then this one is 90. Okay, do you see that? Okay, but B1, let me choose another color. B1, this one, is equals to this one. Why? Because they are subtended by the same arc. They are subtended by the same chord. They are angles in the same segment. Okay, so now we're saying B1 plus B2 is 90 degrees, tangent perpendicular to radius. E1 plus E2 is 90 degrees, angle in the semicircle. But B1 is equals to E1. So it means this and this are equal. Then what does that mean? It means this is equal to this. That's what it means, isn't it? So we can conclude and say B2 is equals to E2. Okay, showing us that this angle here, this one, let me highlight them, is equals to that. So we have proved that an angle made by the tangent and the chord is equal to the angle subtended by that chord in the alternate segment. This angle is equal to this angle. We have proved the theorem. Okay. I hope you're writing notes. Let me give you 1 minute to finish writing notes. So this thing, what you do, you may think that maybe sometimes you even understand. When you get home, put your notes aside. You try proving this thing on your own again. You try. You fail, you refer to your notes. Okay, you try again till you get it. Okay, right, let's try that. Now, 1 minute so that you can finish your notes. Welcome back. Did you manage to finish? I really hope so. Right, let's move on. Now, okay, we are going to prove now the obtuse angle. If you check angle BAE, do you see angle BAE, learners? I hope you can see angle BAE. Okay, can you see angle B? How did I call them here? I said ACB and EAB. Let me use what I've written here. Anyway, it means the same thing, wasn't it? Right, let's look at ACB. Do you see angle ACB? Okay, I don't want to write there because it will make my work clumsy. But now, do you see angle ACB? And do you see angle EAB? Those are obtuse angles. Okay? Right, let me try to write and then I'll erase. This angle here and this angle here. Do you see these two angles? They are more than 90, isn't it? Now, it's the same thing. It's still the angle between the tangent and the chord. And the angle subtended by that chord at the circumference. You see that? It's still the tan chord theorem. Let me try to erase that. Okay. Okay, let me try to pick my pen. Right, and then after this, we're going to do the proof now. Let me see. Okay, perfect. Now, how do we prove this? Same process. We're going to draw the diameter. Okay, I didn't give you time to draw the diagram. 1 minute. Sorry for that. 1 minute. Let's draw the diagram very fast. After 1 minute, then we do the construction. Let's do it. 1 minute. Welcome back, grade 12s. Remember this, most of you have done this. So what I expect from you, grade 12s, I want you to try to be ahead of me. Try that, because you've done this, isn't it? Now try to be ahead of me, and then after that, when I'm doing it, you start to mark your work, okay? Right, now, you do the same thing. Construct your diameter, A or F, from the point of contact through the center to the circumference, and then you name this one F, okay? And then you join. Now be careful, you're joining FC, okay, to this point here, not that, okay, FC. So you're trying to create angles subtended by the same chord here, or angles in the same segment. Remember that, okay? So BF, if you check BF, there is subtending this angle. BF, there's this angle here, and then there's this angle here, subtended by BF, if you can check. These are angles in the same segment, okay? Right, now, what we do? Let's name our angles. Please check your A1. Name this one A1, this one A2, this one C1, this one C2. Let's try that. Okay, name exactly the same, like what I have there. A1, A2, C1, C2. Okay? Right, do you have that? Now, can you say A1 is equal to 90 degrees? Yes, we can. Tangent radius or tangent diameter. Tangent is perpendicular to diameter. You see the reason there? So A1 is equal to 90 degrees. You see that? Okay. Which other angle is equal to 90 degrees? What do you think about C1? It's subtended by what? C1 is subtended by what? By diameter. Do you see that? So it's an angle in the semicircle. So C1 also is 90 degrees because it's an angle in the semicircle. Okay. What about A2 and B2? What can you say about those two angles? They are equal because they're angles in the same segment. They are subtended by BF. If you check here, BF, these two angles are equal. They are subtended by BF, both of them. From BF, you go back to BF, and you go. You see that? They are subtended by that. Right. And then, so they are equal. C2 is equal to A2. Right. Now, this whole angle, ACB, it will be C2 plus C1, isn't it? And then the whole angle AEAB is going to be A2 plus A1. You see? So now, since A1 is equal to C1, and both of them are equal to 90 degrees, and A2 is equal to C2 because their angle is in the same segment, therefore, A1 plus A2 is equal to C1 plus C2. Do you see that? This is equal to this. This is equal to this. So now A1 plus A2 is equal to C1 plus C2. So we're saying these angles, this angle and this angle are equal because this angle here is A1 plus A2. This one is A1 plus A2. These two angles. So they are equal. So do you see that? An angle between the tangent and the chord is equal to the angle subtended by that chord in the alternate segment. Alternate segment. The alternate segment is not always what? The bigger segment. No. It can be the minor segment. In this case, this is our minor segment. Okay? You see that? This is the other segment. So the alternate segment is not like always what? The bigger major segment. No. It can be the minor segment. Okay? Right. So now EAB is equals to ACB. Right. Now, the last method I want us to do. Right, we've done the acute angle and obtuse angle using the same method, but I'm going to do the proof of an acute angle. This is the most common one, the proof of an acute angle, but you may have to know both for acute and obtuse. But now acute angle, another method that you can use. Okay, another method. If you can just spend 1 minute trying to draw this diagram very fast, and then after that I'll try to be fast so that we can use our last 30 minutes productively. Right, now try to draw the diagram just for 1 minute. Welcome back, grade 12. Did you manage to sketch the diagram? What can you do? The other method, maybe you've seen this in the classroom, so we're trying to cater for everyone. I know that some of you did the first method, some of you did this method that I'm going to explain here, okay? Right, depending on what you're taught by sir or ma'am, so it's still fine, okay? Right, now, any of the methods is fine. You can use any, okay? Right, now, what you do, construction, you join your radii. So you join O and B, and you join O and D. Let's do that. Join O and B, and join O and D. That's radii. Radii, remember, they are equal. It's like angles in the English, opposite, equal sides. You remember that, okay? So we have OB and OD. Let's do the construction. Okay, are you happy? Maybe you're doing this method, you know, I know this one, I know this one. I didn't know the first one, but now this one I've done it. Okay, right, but it's good to know both. Okay, so it's good to know both. So now, what do we do? Those who know this method, what do we do? We let angle E be equals to x, isn't it? Let angle E be equals to x. Okay, you can use y if you want, but you remember in mathematics it's just like x. So let E be equal to x. What can you say about angle O2? Even those who have not done this method, you must try. What can you say about angle O2? Right, let's look at BD. It's our chord, isn't it? Our arc. Let's go with BD to the circumference. From BD, go to the circumference, go back to BD, go to the center. You see that? BD, circumference, BD, center. You do that even in the examination. No one is going to be laughing at you. I've never seen someone laughing in the examination, okay? Everyone be serious. So BD, circumference, BD, center. What can you say about O2? It's going to be 2x. Do you agree? The angle at the center is 2 times the angle at the circumference. The angle is subtended by a chord. Let me say it in full. The angle subtended by a chord at the center is 2 times the angle subtended by the same chord at the circumference. Okay? So it means O2 is going to be 2x. Do you agree? Right. And then OB is equals to OD. So what can you say about this angle and this angle? You know isosceles triangles, but we don't use that reason and say isosceles triangles. We say angles opposite equal sides. Okay, so now OBD is equals to ODB because they are angles opposite equal sides. And then now if we add them, this angle, and this angle, we must get 180 degrees. So to find OBD, we can just say 180 minus 2x divided by 2. We're dividing by 2 because these two angles are equal. Okay? 180 minus 2x. And then what we're getting, we're dividing by 2 because this angle is equal to this angle. And then what do you get? What is 180? 180 minus divided by 2, sorry, not minus. 180 divided by 2 is 90. 2x divided by 2 is remain with x. So you remain with 90 minus x. So this angle is 90 minus x. This angle is also 90 minus x. Okay? Right, but what can you say about angle OBC? Please, can you see angle OBC? What can you say about that angle? Is it 90 degrees? Yes, it is. Why is it 90 degrees? Because it's tangent and radius. Tangent is perpendicular to radius. So that is 90 degrees. So now we can find this angle here. We can find this angle here. We just say 90 minus 90 minus x. Because this is 90 minus x, this one. So we subtract this from 90. And then we get something like this. If you remove the bracket, it becomes 90 minus 90. If you remove bracket, this becomes plus x. So this becomes CBD is x. Do you see that this angle here, x, is equal to that angle there? You see that? We have proved that this angle, okay, made by the tangent and the chord is equal to the angle subtended by the same chord in the alternate segment. Tan chord theorem. We have proved that. Okay? Right. So that's a method you can use. I didn't give you time to copy the notes for the previous one. Okay? Right. Can you take 1 minute trying to copy this? And then I'll go back to the last slide. Maybe give you another minute to copy the previous one. Okay, right, 1 minute to copy this. Okay, well done, grade 12s. Let's go back just to the previous slide. Maybe there's someone who did not finish. I just moved fast there and people did not manage to copy the theorems. Please, the proofs are very, very important. These are easy marks because you know that there will be a question about proofs. So let's go back to the previous slide. Okay, I'll try to move fast. No, it's not the previous slide. Okay, it was this one. It was this one. Okay, now just 1 minute. Maybe you wrote halfway. This you can finish off 1 minute, then we move on. Welcome back. Let's continue now. Let's go to our next part of our lesson. We're going to be applying what we've learned. So I'll try to move fast. Please listen. You can apply what you're going to learn now when you're practicing or doing past examination questions. Okay, please do so. Do past examinations. Euclidean geometry you have to do every day. You have to every day. Just do a writer and then you're going to enjoy it. You're going to enjoy it. Okay, right now the converse theorem of the tan chord theorem. If a line drawn through the end point of a chord, making with the chord an angle equal to an angle in the alternate segment, then the line is a tangent to the circle. Okay, that is the converse of the tan chord theorem. So the converse is just the opposite of the thing. Okay, right now I'm going to explain this. I know most of the times I give you time to do your work, but we're left with 20 minutes. We still have to do the tangents drawn from the same point. So allow me to explain this. Please try to take short notes if you can and try to listen so that you can apply what you have learned in the when you're doing what you're studying on your own. Right. ABC is a circle. Okay. Do you see ABC? I check the things that they're talking about. DE is a tangent. Interesting. Once I see tangent, what comes to my mind? Most of the times, I don't know why, I'm always thinking about tan chord theorem. Tangent, just tan chord theorem comes in. Okay, sometimes I even forget about the tangent and radius. Did they mention radius? No. So why worry about tangent radius? Okay, so here, definitely tan chord theorem. Right, DAB is 55 degrees and EAC is 70 degrees. Okay, tangent, I look at my diagram. I can see the chord there. Oh, interesting. So I look at my tangent. I start from the outside of the tangent, go towards the point of contact. So let me start there. I want the x. Let me start with this one. You see, I'm going to draw the line. Okay, you can even highlight. Some people are shy of using highlighters. Highlight, right? There, you see, I'm going towards the point of contact. I get to the point of contact. What angle do I form there? I follow the chord. I follow the chord like that. You see, I formed an angle 70 degrees. You see that? I formed an angle there. Right, and then I look at what that chord subtends at the circumference. So I put one of my fingers there by C, and then I put the other one by A. Okay? And then I follow the lines. I follow the lines like that. You see, I follow the lines, and I'm forming the angle in the alternate segment. I'm forming that angle. The angle that I formed is 70 degrees. It is the angle in the alternate segment. You see how tan chord works. Start from the outside, and then means that x is 70 degrees. You see that? Okay, right. Now, I go to the other side again. I'm going to start from outside. Okay, y is 55. I'm explaining why y is 55. Right, start from outside, draw the line. You get to the point of contact where the tangent contacts the chord. Then the tangent and the chord are forming an angle. You see that? They are forming an angle. Which angle is formed there? 55 degrees. You see? 55 degrees. Now I have that angle formed by the chord and the tangent. Now I look at the chord now. This chord is subtending an angle at the circumference. Which angle is that? I put my what? My fingers there by A and B, and then I follow the lines. Which angle is that? Is it Y? Yes, it is Y. You follow the lines like that, and then you get to Y. Thus, angle Y is 55 degrees. Do you see how nice tan chord theorem is? No one should lose marks on this. These are free marks. Okay? Well done, grade 12s. I said you must listen now, okay, because of time. Right, let's move on. Why is it not moving? Okay, oh no, I'm just deleting things there. Right, let's go to the other one. Right, now, A, B, C, and D are points on the circumference of a circle. EF is the tangent. Interesting. Tan chord. Okay, right. FAC is 125 degrees and EAC is Z. Did they talk about the diameter? Okay, no, but the diameter is there. Maybe I just missed it. AB there is diameter. Interesting. And then I have 4 points on the circumference of a circle. What comes to your mind? I have 4 points on the circumference of a circle. You say, what? A cyclic quad. You see that? So I have cyclic quad, I have tan chord theorem, I have diameter, all those things. It means somehow I have to use it. I have to use them. Right. Now, I want to find x. X is subtended by what? By chord AC. AC. What angle is formed by chord AC and the tangent? It's 125. You see, I follow the chord. Please take note of this. It's not like the chord is always the last chord. People always think the chord is it can be in the middle like this, AC. We have chord AB, we have chord AC, we have chord AD. Please take note of that. Okay? So now we follow the line, and then we follow the chord, and then we form this angle here, which is 125. The chord subtends this angle here at the circumference x. So x is 125 degrees because of what? Because of the tan chord theorem. So x is what? Is 125 degrees, tan chord theorem. Do you agree? Okay? And then we want y. Cyclic quad. What can you say about angle D and angle B? They are angles, opposite angles of a cyclic quad. What do you know about opposite angles of cyclic quad? They are supplementary. They add up to 180 degrees. So if I say 125 plus y, I must get 180 degrees. And then from that, I can get what y is. So we say x plus y is equals to 180 degrees, opposite angles of a cyclic quad, right? And then y is equals to 55 degrees because 180 minus 125 is 55 degrees. So this angle is 55 degrees. Okay, so now, and then we have this angle here, the tangent, and then this one here, the chord, it subtends this angle 55 here. Okay, it subtends the angle 55 there. Okay, now what is angle Z? Angle Z is going to be 55 degrees, the tan chord theorem. Okay, right, because this angle, tangent, chord, and then angle between the tangent and the chord, and then the angle subtended by the chord at the circumference. The angles are equal. Okay, do you see that? Now, prove that. Okay, given triangle ABC, and that CAD is 5x and CAB is x plus 84 and BAE is 2x, right? These are the angles 5x, x plus 84, 2x. We want to prove that DE is what? Is a tangent. DAE is a tangent. It is going to be a tangent if this angle is equal to this angle, or if this angle is equal to this angle. Okay, then if you prove that this angle 5x is equal to 60 degrees, it proves that DAE is a tangent. Remember the converse of the tangent chord theorem. Right, now what do we do? These are angles on a straight line. Adjacent angle is on a straight line. So if I say 5x plus x plus 2x is 8x, isn't it? 8x plus the 84 here. By adding these three, this plus this plus this, you get 8x plus 84 is equal to 180 degrees, because these are adjacent angles on a straight line. Then let's solve for x. Remember, I'm giving you something that you can use later. Please understand that we're running out of time. Right now, we solve for x here. It's going to be 180 degrees minus 84. What do you get? You get 96. Then you divide by 8 on both sides. You get that x is equal to 12 degrees. Then here, it is 5x. You see that? It is 5x. So it means it's going to be 60 degrees, because 5 times 12 is 60. So this angle here is equal to this angle here. Okay, so we can conclude and say DAE is a tangent to the circle through ABC. Why? Because converse of tan chord theorem. Okay, that is that on the tan chord theorem. Right, I want us to look at the last theorem for today's lesson. Okay, which is what? Which is two tangents drawn to a circle from the same point outside the circle are equal in length. Remember that. Okay, you must know how to apply this theorem. Just know how to apply. We're not going to do the proof. You know how to apply this. So I have the point here, which is point what? Point B. Then we're drawing our tangent. Okay, from point B, which is outside the circle, we're drawing another tangent from point B, which is outside the circle, like that. And then we're saying that AB is equals to AC. Remember, don't count this part here. Don't count. It's up to here, the point of contact. The point of contact. We are saying AC, AB is equal to BC. AB is equal to BC. Okay. Remember the tangent and the radius. They are perpendicular to each other, isn't it? So they are perpendicular to each other. Right. Okay. I'll ask you this question. There's an O here, center. Okay, I wanted to give you as a question in the activity, but let me ask you this. Is quadrilateral OABC a cyclic quad? Is quadrilateral OABC a cyclic quad? Can you answer that? How many people said yes? Or how many people said no? It is a cyclic quad. Why? The opposite interior angles are supplementary. 90 plus 90 is 180 degrees. Do you see that? So this is a cyclic quad. Okay? There's a question in the exam that asks people about this, and then people are failing to get it. So 90 plus 90 there is a cyclic quad. Please recognize that. Okay? Right, AB is equal to BC. We have talked about that. Now, I want us to apply this. Do we have time to try? I think we can. We can. I can give you 2 minutes or 3 minutes. Okay? Let me see if I have space for you to work on. Okay, I have. Right, okay. Because this is the last activity for the day. So I want you to read the information. I'm going to give you 2 minutes to try. 2 minutes, just 2 minutes to try. And then after 2 minutes, we'll discuss. Okay? Try to do everything. Find the value of X, the value of Y, the value of Z for 2 minutes. Let's try. Right, welcome back, grade 12s. Did you manage to try? What did you get for X? What did you get for Y? What did you get for Z? Right, A, B, and T are points on a circle. O is the center of the circle. Center theorem. AP and PT are tangents to the circle at point A and T respectively. Tangents from the same point. So the information is very, very, very important, grade 12s. You are going to see that in our next lesson, I'm going to be bringing examination, past examination questions. And please know that you are going to be working through the questions, then I give you answers after that. So that's what we're going to be doing in next week. Past examination questions. Please don't miss the lessons. Very, very important. We're going to be working on the writers. Right. So very, very important. It's very, very important for you to read the information because it assists you to answer the question. Okay. Right. Now, and then what we have here, calculate the value of X. So we're saying X is equal to AP is equal to PT, tangents from the same point. That's the reason you write. So it means AP and PT are equal. Okay. So X and PTA, this one, this angle here. It means this angle also is equal to X because these are angles opposite equal sides. AP is equal to PT. So it means PTA is also X. So now, if you say 40 plus X, we must get 180 degrees, isn't it? Okay? So 40 plus 2x is equal to 180 degrees. So we can as well say 180 degrees minus 40 and then divided by 2. We get our x value. Okay. So so now maybe people, this one moves very fast and people get confused. Let me just do it here. So it's 40 plus 2x is equals to 180 degrees. Okay, so we say 2x is equals to 180 degrees minus 40 degrees. And then to get your x, you say x is equals to 180 degrees minus 40 degrees divided by 2. This is where this one is coming from. Every time when I'm dealing with angles opposite equal sides, I usually use this, but I really hope that you don't get confused. So x here is going to be equal to what? Is going to be equal to 70 degrees. So this is 70 degrees and this one is 70 degrees. Okay? Right. This is a tangent. This is a tangent. So now what will be x is 70 degrees? What did you write here? Y? No. Okay, let's go back. Right, no, it's fine. This is the tangent. This is the chord. Okay, this is the chord. You see that? And then this chord forms the angle y here. So it means this angle is equal to this angle. So y is also 70 degrees. Do you agree? Okay. Do you agree that? So that y is equal to 70 degrees because of the tan chord theorem. Okay. What about this angle? I was thinking about this angle here. This is 90 degrees, isn't it? Because radius and tangent. Okay. But y is 70 degrees because of the tan chord theorem. So what are we left with? We want to find z. Right. Let's start from 80 to the circumference, then 80 to the center. 80 circumference, 80 to the center. What is going to be z? Z is going to be 140 degrees. Why 140 degrees? Because an angle subtended by a chord at the center is 2 times the angle subtended by the same chord at the circumference. Well done, grade 12s. We're done with today's lesson. Right, we just need to summarize our lesson. Let's summarize our lesson. Right, the tangent to a circle is perpendicular to the radius or diameter of the circle at the point of contact. Do you remember this? Don't forget it. If a line is drawn perpendicular to a radius or diameter at the point of contact, or at the point where the radius and diameter meets the circle, then the line is a tangent to the circle. The converse of that. 2 tangents drawn to a circle from the same point outside the circle are equal in length. We just did that. Okay? Right. And then the angle between the tangent to a circle and the chord drawn from the point of contact is equal to the angle in the alternate segment, the tan chord theorem. And then the converse, if a line is drawn through the end point of a chord, making with the chord an angle equal to the angle in the alternate segment, then the line is a tangent to the circle. Okay, that's what we have learned today. Right. Well done, grade 12s. I really hope that you learned something in today's lesson. Remember what we're going to be doing in our next lesson. We are bringing in now all the theorems that we have learned. From the first one up to the last one. We're going to be bringing all the theorems now, and we are looking at how the examiners ask you in the examination and how you are expected to answer them. Okay? Right. Really make sure that you continue working hard and you continue trying, and remember to sanitize, to social distance, and to wear your mask. Take care of each other. Let's meet again in the next lesson. Goodbye.